Hey everyone, welcome back to Edgeverse. Or if you're new here, hit that subscribe button right now because we're diving deep into the cutting-edge world of AI. Imagine this. An open-source AI model drops out of nowhere in late 2024 and it suddenly matches, or even beats, secretive beasts like OpenAI's O1 on tough reasoning tasks. We're talking math problems, coding challenges, the works. The community goes wild. This is DeepSeek-R1. And it seemed like proof that reinforcement learning could unlock true reasoning in large language models without needing billions from big tech. But what if a lot of that hype was built on shaky ground? What if the breakthrough algorithm behind it has hidden flaws that artificially boost performance? And what if those amazing reasoning gains are mostly just pulling out stuff the model already knew from pre-training? Today, we're breaking it all down. We're looking at the fundamental flaws in how we're using RL to train these models, specifically DeepSeek-R1 and its key trick, Group Relative Policy Optimization, or GRPO. Stick around, because this could change how you think about the next wave of AI progress. First, let's set the stage. Why did DeepSeek-R1 feel so revolutionary? Traditional ways to make LLMs reason better, like what OpenAI did with O1, rely on reinforcement learning, basically rewarding the model for good answers and penalizing bad ones. But the classic method, proximal policy optimization or PPO, is a resource hog. It needs multiple huge networks running at once. The main model, a critic to judge value, and a reference model to keep things stable. Enter GRPO. It's smarter, or at least more efficient. Instead of a separate critic network, GRPO generates a bunch of possible responses for each question, scores them, and uses relative comparisons within that group to update the model. No extra massive network needed. Less memory, faster training. DeepSeek used this to build R1, and boom, performance rivaling closed models, all open source. Sounds perfect, right? But here's where it gets interesting. Recent papers and analyses have poked serious holes in this approach. Let's talk about the biggest red flag, response length bias. During training on an early version called DeepSeek-R1-0, researchers noticed responses getting longer and longer. Everyone thought, awesome, longer chain of thought means better reasoning. You know, the model is thinking step by step more deeply. But nope, it turns out this is largely an artifact of how GRPO is implemented. They normalize the gradients by dividing by the length of the response, a common trick borrowed from pre-training. Here's the problem. Short correct answers get their gradients amplified because you're dividing by a small number. Long wrong answers get dampened because you're dividing by a big number. Result? The model learns that spitting out longer text is safer or more rewarding, even if it's not better reasoning. It's like the algorithm is cheating to make responses look more thoughtful. This isn't emergent intelligence. It's a mathematical bias sneaking in. There's more. GRPO also has a question difficulty bias. When it normalizes advantages by the group's standard deviation, easy questions, where most responses are correct, end up dominating the training signal. Hard questions, with more varied scores, get downweighted. So the model gets really good at easy stuff, but doesn't push as hard on the challenging problems that actually build real reasoning. Researchers have already proposed a fix, something playfully called Dr. GRPO, GRPO done right. It strips out these faulty normalizations, keeps the efficiency, and gives cleaner learning. Early tests show it works better without the bloat. Okay, pause for a second. Rhetorical question. If these biases are inflating performance, are we really seeing new reasoning emerge from RL, or just better extraction of what was already baked in during pre-training? That's the next big critique. Some analyses argue that a lot of these RL gains follow plain old pre-training scaling laws. Base models, like DeepSeek, V3 or Qwen 2.5, already show strong reasoning latent abilities. RL with GRPO might just be organizing and surfacing that knowledge more effectively, not creating brand new capabilities. Think about it. If you prompt a base model the right way, it can already do long chains of thought. RL helps it do that consistently, but it might not be inventing reasoning from scratch. This narrows what we can expect from post-training RL. It's polishing, not revolutionizing. Now, let's get a bit more technical. There's a sneaky bug that's even harder to spot: numerical precision issues. Most training happens in BF16, float 16, because it handles big gradient swings well. But inference or rollouts might use FP16. Different frameworks handle these formats slightly differently, and tiny rounding errors build up during RL. In RL, you're making superfine relative comparisons between rewards. Those tiny mismatches can destabilize everything. Turns out, for RL fine-tuning, raw precision often matters more than dynamic range. So FP16, used consistently, can actually be more stable than BF16. Big labs like OpenAI or Anthropic probably hit these walls, but patch them quietly with custom code or just restart trainings. Open source folks, we feel the pain directly, making reproduction tough. DeepSeek-R1 itself improved on the 0 version with a smarter pipeline, starting with supervised fine-tuning, mixing and rejection sampling, adding rewards for formatting and language consistency. They avoided fancy neural reward models, sticking to rule-based ones to prevent hacking. And for smaller models, they just distilled knowledge via synthetic data, no RL at all. Those 7B models punch above their weight. But again, is that true reasoning or memorized patterns? This gap between frontier labs and open source is huge. Big players mask flaws with scale and engineering. Open source exposes them, which is good for science, but frustrating for reproducibility. So, where do we go from here? Short term, we need better benchmarks that actually measure reasoning process, not just final answers. Fix algorithms like Dr. GRPO. Standardize precision handling. Medium term, hybrid training methods. Deeper theory on how scale affects these algorithms. Long term, move beyond benchmark chasing toward real-world useful AI, scientific discovery, efficiency, societal good. And figure out once and for all what pre-training versus RL really contributes. Look, DeepSeek-R1 is still an impressive achievement. It proved open models can compete on reasoning tasks. But these critiques show we're not there yet on reliable, theoretically sound RL for LLMs. The flaws, biases, precision bugs, attribution issues mean we have to be cautious about overhyping emergent reasoning. The good news? The community's already calling this out and proposing fixes. That's how science advances. What do you think? Is GRPO salvageable, or do we need a completely new approach to RL for language models? Drop your thoughts in the comments. I read them all. If this video made you rethink the AI hype cycle, smash that like button, subscribe for more no BS deep dives into AI research, and hit the bell so you don't miss the next one. Thanks for watching, and I'll see you in the next video.